Hello guys, so today we're going to be doing Leetcode 20 invalid parentheses. It's a Leetcode easy and it's a really good problem when you're being introduced to stacks. So it says given a string S containing just characters opening parentheses, closing parentheses, open bracket, closing bracket, and determine if the input string is valid. An input string is valid if one open bracket must be closed by the same type of brackets. So you can see down here in example 1, the opening bracket is closed by the same parentheses, right? So it returns true. And down here returns false because opening parentheses is closed by a closing bracket, which would obviously return false. Opening brackets must be closed in the correct order. So you can see right here, this is all closed in the same correct order. Every closed bracket has a corresponding opening bracket of the same type. So yeah, like I said, this problem is a really good problem when you first are introduced to stacks. And the go-to solution to this is here. Let me just screenshot this question over. All right, yeah. So, like I said, the go-to solution to this is using a stack, but you would always also want to use a hashmap to reference. You can use a dictionary or a hashmap to reference the closing bracket and the opening bracket, and then all you have to do is just loop through it and make a stack. So you're gonna push an opening bracket onto the stack, and then every time there's a closing bracket, you're gonna want to check the dictionary and it'll be able to match the opening bracket with it. So basically, to better explain and visualize, let's say we have a string called S equals this, something simple. So on the stack, we're gonna push the opening bracket, right? But whenever we see a closing bracket, we're gonna check if there's a matching corresponding opening bracket. And if there is, then you're gonna pop the stack and return true when the stack is empty. And basically, you might be wondering, how are we going to be able to reference the bracket to bracket? And like I said earlier, we're going to be using a dictionary, and we're going to such as like this, like dict equals so it's going to have a closing bracket first, which is the key, and matching with this, and so on, right? You're going to have 3 pairs because it mentions there's 3 pairs right here. But yeah, that's basically the solution to it. Time complexity is O of n. And the space complexity is also O of n because the input can also grow with the stack. So it will be O of n as well. Okay, so let's get this out of the way. Let's talk about complexity, O of n. This is because the input will grow with the stack. Okay, so we're gonna initialize a stack, and then basically, like I said, we're gonna make a dictionary to hold in all of these values, the pairs. It doesn't matter if you start off with the closing bracket or opening bracket, but I want to push the opening bracket onto the stack. But some people, when they do this problem, they actually push the closing bracket and they check if the closing bracket is the same. So like if they do this problem, if they push like a closing bracket, right, and you have like this, so when you see an opening bracket, you actually push a closing bracket, and then on the next iteration they check this value. If this value matches onto the stack, then they pop it. So that's a pretty good go-to method as well. But for my solution, I'm going to be showing where I push the opening bracket onto the stack. And sorry, this might take a while because I'm trying to form the pairs. So there's 3 pairs right here. Opening bracket, this should be a closing bracket right here. Opening bracket. Yep, that's correct. Okay, so now you're gonna want to do for char and the string. So this is our character and each index in the string, right? So if char is inside the dictionary that we made, right? If char and dictionary, so if this exists inside if this exists inside the dictionary. You're gonna want to have an if statement if the stack exists and the top of the stack, or actually the dictionary char equals the top of the stack. Right, so this represents the top of the stack. So if the stack exists and this exists, and it's equal to the top of the stack, all you want to do is just pop the stack. Right? Else, this is like when you see an opening bracket, because you can push as much opening brackets as you want. You can just stack the append. You can just stack the append char. Else stack the append char. So this is for this if statement right here. If char in dictionary, else stack the append. And when you want to return, you only want to return if the stack is empty. So you return not true if not stack, and else false. So you don't want to return true if the stack is not empty, right? So if the stack is empty, you can return true. But let's run it and see if this works. Let's see if there's no syntax errors. Yep. And it's a pretty efficient solution too. Like I said, it's linear. And yeah. Well, yeah, that looks like a pretty good solution. But yeah, that's all for the video today. Thank you guys.